Now we see it gone a little bit too quickly. Take a moment with me and see if we can match these signs. I would say this should be x minus 1 and x plus 4. If we do this, we'll have an x squared minus x and a plus 4x. That's going to work fine. And so make the correction as appropriate. So we have either x equals negative 4 or x equals 1 as our two solutions. If you're not careful, if you're going on autopilot, if you're solving a problem where you've solved it before, you think you're done at this point. You can put a box around it and move on, except we've just learned a bitter lesson. It doesn't always work. Sometimes the values we find aren't permitted, sometimes they are extraneous roots. Shall we check? The solution x equals 1, does it make sense here? Can I find the base 4 log of 1? Yes, the base 4 log of 1 is 0. Can I find the base 4 log of 1 plus 3? Indeed I can. This shouldn't be difficult. What about the solution x equals negative 4? Can I find the base 4 log of negative 4? No, 100 times no. The domain of logarithms is only positive numbers. We can't put negative numbers in. This is one of our extraneous roots. Our false solutions, our false friends, something we cannot trust and cannot use. There is only one solution to this, which is the solution x equals 1. Note then, when we have something like a logarithm equation, it's exactly like we've done since algebra, except for two things. One, you have to use laws of logarithms in the first steps until you get rid of the logarithms. We have to combine logarithms, or take apart logarithms, or move terms around the way we have been doing for the last several days. The second trick is when you're done, always check to see whether your roots are extraneous. Let's move on to inequalities. We've solved equalities and solving were done almost the same way as everything we've been doing with equalities since algebra class. Inequalities too are done almost the same way, except for one little caveat, and that one little caveat, again, like it was before, involves the domain. Once again, we have to be careful. Just make sure we take advantage of the fact that the domain is always positive. So let's try one of these. Solve the following inequality. I want to solve the natural log of 4 minus 7x is less than or equal to 1. It looks like the sort of inequality we're used to solving. There's an expression on the left side. There's a less than sign. There's a 1 on the right side. What do we do? And the first thing we have to do, at the very beginning, before we forget, first check the domain. What are the values I should even be thinking about as I solve this inequality? What are the things I'm permitted to look at? And I know for sure this thing inside the logarithm, it's called the argument, if you like vocabulary words, the argument of the logarithms, this thing inside the parentheses must be positive. I must have that this 4 minus 7x thing is a positive number, which means it must be the case that 4 is bigger than 7x, which means that 4/7 is bigger than x, or if you prefer it the other way, x is less than or equal to 4/7. Note what we've done here. We haven't even looked at this less than 1. We haven't actually solved the inequality. We've only asked ourselves, which values are we allowed to consider? The only values we can even consider for this problem, the only one that it makes sense to look at, the only ones for which the log of 4 minus 7x are defined, are those x which are less than 4/7. Having found those, we can now move on to the second step, which is to actually solve the inequality. In the inequality I have, what? The natural log of 4 minus 7x is less than or equal to 1. Now I want to get rid of the natural logs. I actually want to solve this. We know the best way to get rid of natural logs is to take e to the power of both sides. E to the power of the natural log of 4 minus 7x is simply 4 minus 7x. E to the power of 1 is just e. To solve for x, what can we do? I could either move the 4 over and divide by negative 7. I remember that dividing and multiplying by negative signs in the inequalities is kind of confusing. You have to switch them backwards, you might forget. I say, why bother? If it's going to be hard, let's just not do it. In fact, let's just add 7x to both sides. 4 is less than or equal to e plus 7x. Now I can subtract e from both sides. And this way I'll only have to deal with positive coefficients of x. If you prefer solving this problem the other way, you can. It will work out fine. But Why bother putting in one more difficult step if we don't need it? Now I can simply divide and find that x is bigger than 4 minus e over 7. What do I know now? I know x must be bigger than 4 minus e over 7. I know it must be less than 4 over 7, and so we can combine these to find the actual result of the inequality. For this original inequality, the only values of x for which this holds, here's some values that are less than x. 4 minus e over 7 must be less than x, and x itself must be less than 4 over 7. Now that I write this at the end, I see I made one small error earlier in the problem. Did you catch it? Bonus points if you caught it. Hereby awarded. Bonus points if you caught it. What's going on? Do we need this to be greater than or equal to 0? No, we really need it to be positive. I can't have the greater than or equal to here. The thing inside the logarithm has to actually be a positive number. So we need to get rid of all of these equal signs here. We'll end up with less than or equal to on the bottom, but only the greater than on the top. So once again, let's step back and think about what we've done. What we've done is not difficult. To solve a logarithmic expression, we maybe first use properties of logarithms to combine complicatedness into one logarithm. We get rid of the logarithm simply by rewriting the formula. This is something that we're good at. And we solve the inequality the way we always do, with the same basic caveat. And that caveat is really the take-home message for today's lesson. Always make sure you check the domain. Always make sure your values are plugged back in. Always make sure if you're taking the natural log of something, that something is positive. With that, we stop here. We move on tomorrow to new laws of logarithms, new properties, and new applications. Thank you.